For today, let's look at this number theory question, which I will use a technique from inequality. Suppose a, b, c are positive integers such that the sum of the square equals to 2025. You are asked to prove that the sum of a, b, c is not a perfect square. Please have a good try before you look at the answer.
Pause the video now if you wish to solve it. Keep watching the video once ready.
We are going to prove this statement by contradiction. So we say suppose not, let a plus b plus c be a perfect square and say it is k square for some positive integer k. And therefore k square goes to a plus b plus c, which you know from the result of inequality, this is less than or equals to square root of 3 square root of a square plus b square plus c square. And since the sum of square equals to 2025, this is square root of 3 square root of 2025. And obviously, this is less than 80. Since a square plus b square plus c square is an odd number, then a plus b plus c is an odd number as well. If it's equal to k square, where k square is less than 80, then it means that k square must be either 1 square, 3 square, 5 square, or 7 square. We also know that the square of the sum will be greater than or equal to the sum of the square, since a, b, c are positive integers. And this is equal to 2025. And since the sum of a, b, c equals to k square, this will equal to k to the power of 4. And note that 2025 itself is 45 square. So this means that k square itself is greater than or equal to 45. Which means that k square cannot be equal to 1 square or 3 square or 5 square. And therefore, k square has to be equal to 49. Now what we have here is a plus b plus c equals to 49 and a square plus b square plus c square equals to 2025. Now this means that b plus c equals to 49 minus a, and b square plus c square equals to 2025 minus a square. Again, using the result from inequality, b plus c square must be strictly greater than b square plus c square because b and c are positive. So what we have here is 49 minus a square is therefore greater than 2025 minus a square. And this means that after we expand it and rearrange the term, eventually we'll have a square minus 49a plus 183 greater than 0. Which means that a must be greater than 44.8 or a is less than 4.2. If you enjoyed this video, please like, comment and subscribe. Now if this is the case, this means that a must be at least equal to 45, and hence a square will be greater than or equal to 45 square, which is 2025, and this means that b and c cannot be a positive value anymore. So we have to reject this one. However, for a less than 4.2, it means that a must be less than or equal to 4. Using the similar argument, we can also argue that b must be also less than or equal to 4, c must be also less than or equal to 4. This means that the sum of a, b, c must be less than or equal to 12. But this is a contradiction because we say that the sum is equal to 49 and this is clearly less than 49. So this concludes that the assumption is not correct, which means that a plus b plus c is never a perfect square. Of course, there's another possible way to solve this question, that is, go and find all the possible value of a, b, c and verify the sum is never equal to k squared. But that process is very tedious. To conclude, I use some technique in inequality and the idea of quadratic equation to solve this number theory question. That's all for today's lesson. I'll see you again next time. Bye bye.